Okay, this is day 5, some BC practice, more BC practice with polars. Okay, so finding the slope of a tangent line. Finding the slope of the tangent line means finding what? The derivative in terms of what? Y and x, right? In this case, I have an r and I have a theta. But I do know that x equals r cosine theta and y equals r sine theta. So what I'm going to do is if x equals r cosine theta, I'm probably going to run out of room, which is okay. What could I plug in here for r? Yeah, 1 plus sine theta. Okay, so now if I want dx d theta, I would take d theta of both sides of this. Okay. What I would probably do is, before doing that, I would distribute. And I'd get cosine theta plus sine theta cosine theta. So it looks like I'll have to do some product rule there, but it's not difficult. Okay, so I'd get dx d theta is equal to, what would that be, negative sine theta. Let's product rule this thing together. Derivative of the first would be what? Cosine, so that'd be cosine times cosine, which would be cosine squared, plus first times the derivative of the second. What's the derivative of cosine? Negative sine. So I'd have sine times negative sine, which would be negative sine squared. So that right there would be dx d theta. So I just took the derivative of cosine, got negative sine, took the product rule derivative of said thing, sine, cosine, and got cosine squared minus sine squared. Now that's not equal to 1. It's not cosine squared plus sine squared. So I have cosine squared minus sine squared, and then this minus sine at the end. Okay, so I'm going to get rid of all this if you're okay with that, just to save some space. And using x equals r cosine theta, I now know dx d theta equals this. I would not try to simplify that using any sort of identities. I just leave it. Just leave it right there. Okay, let's do dy d theta. Okay, so y equals r sine theta. So then y equals 1 plus sine theta times sine theta, which would be what? Sine plus what? Sine squared. Yeah. So I'd get sine plus sine squared theta. Now let's take the derivative of that in terms of theta, d theta. Okay, so that'd be dy d theta would equal cosine theta. Now, what do we got to do here? Product chain, just normal chain, right? We got to work outside in, so I'm going to take, and I'm going to bring down that 2. So I'd have 2 sine theta, and then the derivative of the inside. What's the derivative of sine? Cosine. Good. So that would be dy d theta. Now, if I want the slope, uh-oh, that was bad news. If I want the slope of, ooh, I'm going to do this. Oh, come on. Hello. If I want the slope of this polar curve at pi over 3, I'm going to take dy d theta over dx d theta, which will give me what? Dy dx. So I'm going to take cosine of theta plus 2 sine theta cosine theta. Put it over dx d theta, which is negative sine theta plus cosine squared theta minus sine squared theta. This is now dy dx. And I want to know what that's equal to at theta equals pi over 3. Let's pause the video here, do a substitution here, see if you can do it. That's a nice unit circle number, so we potentially could do this without a calculator. Try it without a calculator. Let's get an exact value, and then We'll do same thing with calculator. Let's go. So it looks like if I plug in a pi over 3 here, check out what happens here. I get a 1/2 for cosine of pi over 3. I get 2 times the square root of 3 over 2 times 1/2, but this 2 only cancels one of those 2's, so I get root 3 over 2. So that's 1 plus root 3 all over 2. Down here, what do these two combine to? Negative 1/2, so I pull out a negative. That makes this 1 plus root 3 over 2, and that, in turn, because I have a positive or negative, gives me a slope of -1. Yes, ma'am. This should be a calculator problem. It will be. What would you type in, and how would you do it? Well, yeah. Or what you could do is for dy d theta, you could type this into, say, y1, and then evaluate. Just do this, y1 of pi over 3, and then divide that by, and then you could put in for y2, that was dx d theta. You could put this in for y2, and shoot, you would want it the other way around. So I would do this over that, and you'd get a nice answer. So the hard part would be typing this in for y2 and this in for y1 and making sure you didn't screw it up, because then the calculator does the rest. You get -1 for a slope, all right, and you're good. Abstract, though, in nature, because now we've got 4 variables involved. We've got an r, we got a theta, we got a y, we got an x. And it's annoying, but if you know the mechanics of how dy dx relates to dy d theta and dx d theta, it's not that bad. Not easy to see here, at least from my perspective, but it says find points of the cardioid where the tangent line is horizontal. So the tangent line will be horizontal in 3 places. I want to identify one that is never going to be differentiable. But there's one, agreed? Horizontal tangent line. Here's another. Here's another. This point right here is not. That is not. That is not going to be a horizontal tangent because it's a cusp. It's not a smooth curve. It's not differentiable at that point. So let's find these 3 points. How would we do that? Find point function. Well, I don't want to find the point. Well, I do want to find the point, don't I? Yeah, I do. But what do I want to know there? What's changing there? Is x changing there? Is x moving horizontally there? Yes. Is y moving vertically there? No. So what is dy d theta equal to? 0. So I take dy d theta, and I set that equal to 0. Could somebody tell me what I had for dy d theta? No, the function from above. The function from above. Cosine theta plus 2 sine theta cosine theta. Okay. I want to know, and this was kind of like a final exam question. Some of you are like, what am I supposed to find? You're going to find theta. Yeah, so what can I factor out of both of these? I could factor out a cosine. What's left over? 2 sine theta plus what? Plus 1. Or 1 plus 2 sine theta, or 2 sine theta, right? If I factor out I'll do it that way so that the childs don't get confused. Too late? If I factor a cosine out of the first term, I get a 1. If I factor a cosine out of the second term, I get a 2 sine theta. Now, this is going back to algebra where all we need to do is the zero product property to find out what values of theta will give me 0. Yeah, go ahead. Right? Dx d theta would be 0 here and here. Because that's where x is not changing. That's where x, you can think of it as particle motion. That's where the x portion of that coordinate is at rest, but the y is changing. And then all of a sudden the x kicks back in. Yeah. Right? So at these red points, which we're going to isolate here, we're going to find a green one, though, that's not because it's not differentiable there. But we're going to solve this equation using the zero product property. That's back to algebra in order to find theta at those points. Okay, so let me go back to the old algebra life that you lived at one point, and maybe you're still working on it. But how would I find x values that would give me 0 here? Well, I'd factor out an x, and what would I do? I'd set this equal to 0. Right? Oh, so if x equals 0, that'd be 0. And if x equals what? 4. Okay, I'm going to do the same thing here. If cosine theta equals 0, this whole thing would be 0. Well, what are the values for cosine theta that give me 0? Pi over 2 and 3 pi over 2. That's only with complex. Only with complex do I want my angles in that negative theta, or negative pi to pi. I don't think so. I don't think they would take off points there. 1 plus 2 sine theta equals 0. That would mean that 2 sine theta, we gave you unit circle numbers, which is great. Oops, I didn't want that yet. All right, negative 1, and then sine theta would equal negative 1/2. Well, where does that happen? At 7 pi over 6 and what? 11 pi over 6. Right, unit circle, here I go. Bam, 7 pi over 6. That would be a negative 1/2, and so would 11 pi over 6 right there. Okay, so let's identify which of these doesn't exist. Right? Here's a nice way to kind of visualize this. I think of it this way. As I look at this sketch, this is an obvious one. What is that? Pi over what? 2. Right? This one and this one, those look to be the 7 pi over 6 and 11 pi over 6. And the green one that doesn't exist would be the 3 pi over 2. So how would I know for sure that the green one is the one that doesn't exist? Well, you could plug 3 pi over 2 into the original function. Let's see what we get. Up here for r. R was 1 plus sine of theta. We're saying theta is 3 pi over 2. What's the sine of 3 pi over 2? Negative 1. What does that equal? 0. Where is that point located here? At 0, 0, right? Or at 3 pi over 2, 0. It's got a radius of 0 and an angle of rotation of 3 pi over 2. Well, it's not going to move then. Okay.